Hello and welcome to ATI 4448. As we said in the previous session, to develop the project schedule, we can use the either Microsoft project, which was explained before, and we are going to revisit at the end of this session, or we can use the network diagram, or both of them, and the critical path analysis, which will be explained in this session. So let's start looking at the constructing of the project network diagram and see how that will work. First of all, we need to understand what is the project network diagram. The project network diagram is a pictorial representation of the sequence in which the project work can be done. In simple words, we are looking at the sequence of activities, which one comes first, which is the predecessor or the successor of each task. To do that, we use the first session or the previous session to actually identify the tasks or the activities, estimate the duration. We learned the different tools and techniques to estimate the duration, and then we need the earliest time to start the task, the earliest expected to complete the task, and the sequence of these activities, which all again we did in the previous session. So now we understand how to prepare the network diagram having these information. The advantages of a network diagram: it's good for the planning, for the schedule. So it's a visual overview of the project that is easy to use, to look at the schedule, to look at the time frame, and to analyze the different tasks, even in a detailed task orientation or basis. And then we have the implementation. Software exists that automatically update task dates and duration, such as Microsoft project or the network diagram that we are going to use through Visio or other software packages. The control, it helps the project manager to better look at the schedule and spot the variances, discrepancies, or problems with the schedule or the delays in the schedule, and of course to act upon that. The early method of building a diagram was a task on arrow, or what we say activity on arrow, either TOA or AOA, it doesn't matter, either task or activity. And by saying that, as you can see the activity A is actually added to the arrow and not inside the node. So this is called task on the arrow or activity on the arrow. The other diagram, or the new diagram, is called the precedence diagramming method, PDM, or activity on node diagram. In the activity on node diagram, as you can see here, the activities are written within the node. So it's not on the arrow, it's inside the node. If you compare the two, the activity on node and the activity on arrow network conventions, you can see that both are the same. Basically, when you have the activity inside the node, you are saving more space than having it on the arrow. For 3 activities, we need 3 nodes, while for the activity on the arrow, for 3 activities, you need 4 nodes and 3 arrows. So it takes more space to explain that. But otherwise, they're the same. So if you look at the different representations, when we have A and B before C, you can use the activity on node in this way, while in the activity on arrow in this way. And again, if A is the predecessor for both B and C, then we can use it or show it like this in the activity on node, while like this one on the activity on arrow. So let's use the new diagramming method, which is the PDM, or the activity on node, and see how we can use that to identify or build the network for a project. We need to define in this node the estimated time or the expected time or the duration of the task. We need to have the task ID or name. We need the earliest start and earliest finish. We need the latest start and latest finish, and we need to calculate slack if we have a slack of time extra for this task that we can utilize later on in other things. So those are the information needed for the task that we are going to build or use to build the network diagram. We are going to determine the sequence of tasks, and every task has to at least or has at least one predecessor, unless it's the first one, and at least one successor. Exceptions: the start task has no predecessor and the end task has no successor, of course. Using the precedence diagramming method to identify the type of dependency, that's important, so we know that finish to start or finish to finish, start to start or start to finish, and I explained the meaning of these dependencies in the previous session, but you can understand it more from the slide after this one, and that will show you exactly what do we mean by finish to start. So when A finishes, B may start. B may start, and this is how it shows in the diagram. While if finish to finish, then when A finishes, B may finish. So B can start anytime, but it will not be considered as finish or done unless we finish A first. Start to start: when A starts, B may start. Again, we don't care about the time when it starts, but we are not allowed to start B before A, but once we start A, we can start B at any time. The start to finish is when A starts, B may finish, so B will not be able to be considered as finished until we actually start A. So we need to choose the right dependency or dependency type, where we identify the predecessors to task, and to do that we ask the question, what does this task need before it can start? Identifying predecessors is often easier than finding the successors. And then we need to determine whether the start or finish of the predecessor controls the scheduling of the successor. For example, if the finish of the predecessor controls the second task, the dependency type must be either finish to finish or finish to start. We need also to determine whether the predecessor triggers the start or finish of the successor. For example, the result of the previous step is finish, and the result for this step is start. The dependency type is finish to start. To further define the task relationships, identify whether the dependency uses lead time or lag time. In project, you can further qualify the relationship between two tasks with a lag or a lead. For example, if you can't start to add the second coat of paint until the first coat has dried. The finish to start dependency between the paint first coat task and the paint second coat task include a 4-hour lag. So although the first task finished, but the second task cannot be started until 4 hours later, so we have a lag time of 4 hours. We need also to determine the constraints for the task dependencies. We have 4 different types of constraints. We have technical constraints, we have management constraints, inter-project constraints, and data constraints. For the technical constraints, such as the wait task may need output from a previous task before they may begin. So I need to wait for the output to be done or to be given to me, the results to be given to us, so I can start the next task. For management, such as meeting competitive pressure or get things done before a major event, such a holiday or a conference. So if you need to finish a product before or sell it in Christmas, so you need to finish it before Christmas, before that holiday. Otherwise, you will miss the point of selling that product as a Christmas product. Inter-project constraints, such as the need for a related project to finish their side of an interface before yours can be fully tested. The data constraints were a specific event guides and activities, such as needing tasks done no earlier than or no later than or in a specific day. For the lag, it's a variable that can be used to specify the delay between tasks or events. The example of paint task, painting the wall, and for the first coat and second coat, we can see or realize the variability of the lag time. Also, lag can be positive or negative, and it can be international, also created by or controlled by constraints. Creating the initial project, or to create the initial schedule or network diagram, we compute 2 schedules. We need to compute the early schedule, which can be done using the forward pass, or the late schedule, which can be used or can be calculated using the backward pass. And those 2 shapes here shows the 2 different passes or calculations. One of the other things that a manager would like to look at for the control and for reporting and monitoring the project is the critical path. The critical path is the longest duration path in the network diagram, the most that it can be. So it is considered the shortest time in which the project can be completed. It cannot be completed before that because each task has a certain time it has to be done within that, and we cannot actually crash that task more than that. That's it. So it's the shortest time. It's the longest duration. It is the sequence of tasks whose early schedule and late schedule are the same. Whether we schedule it early, late, they're the same. We don't have any lags, any slacks. So we have 0 slacks. So it's the sequence of tasks with 0 slacks or floats. The critical path determines the completion date of the project. So if I know that the critical path is 25 days, then I know that the project will be completed or can be completed within 25 days. The critical path determines the completion date of the project. Let's go over an example, and this example will take me through the creation or building the network diagram, how to calculate the critical path, how to go forward pass, backward pass, and how to we'll use the same example to create the network diagram in Visio and in Microsoft Project. So let's look at this example. This example is a diagram or a project for our Milwaukee paper company, and we need to build or develop the network diagram for this project and perform critical path analysis. We have 8 tasks. We have duration for each task, and we have the predecessors. Looking at the table, we need to determine the project schedule using the earliest start, earliest finish, latest start, and latest finish for each task. For the early start means at which an activity can start assuming all predecessors have been completed, and that's the early start for a task. The earliest finish is the earliest time at which an activity can be finished. The late start, the latest time at which an activity can start so as to not delay the completion time of the entire project. Latest finish is the latest time by which an activity has to be finished so as to not delay the completion time of the entire project. And we are going to document that in the network diagram. This network diagram is circle, sometimes it's rectangular. It does not matter the shape. The most important thing is to use nodes that are in a sequence, represent the different tasks within the project, identify the project processes, and the critical path. That's it. Whether it's circle, rectangular, it does not matter what or what kind of representation are you using. So I will use the circular for the example in this one. Then I will use a rectangular through Visio and Microsoft Project. So we can actually use the activity name or symbol or ID in the middle with the duration also. The early start will be in this corner, and the early finish will be in this corner, and then the late start in this corner down here, and the latest finish in this corner. So let's go with the forward pass. If any activity has only a single immediate predecessor, its earliest start equals to the earliest finish of the predecessor. So if I'm going to finish task number one at or on Friday, then I can start task number 2 on Friday. If I can finish on Monday, then I will start on Monday. I don't have to wait until Monday unless it's specified that you have to wait until the finish of Friday 5 p.m. and then we identify the start of Monday at 8 a.m. If that's specified or that's how it's been done or finished, then that will be it. But we cannot start the successor without finishing the predecessor. So the early start for the predecessor or for the successor is the early finish for the predecessor. And if an activity has multiple immediate predecessors, its early start is the maximum of all of the earliest finish values of its predecessor. Actually, you will understand that once we start going over the network diagram and building the diagram. The same for the earliest finish time rule. The earliest finish time of an activity is the sum of its earliest start time and the activity duration. So early finish is equal to early start plus activity duration. Let's see how this can be done. So let's start, and with the start node we have 0. You can use a start node and you can just create the network diagram without a starting node. It doesn't matter, but this is just for organization purposes. I would like to start with a 0 node, 0 duration. So the name is start. It has 0 duration. Early start is 0. Since the early start is 0 and the duration is 0, 0 plus 0, then the earliest finish is 0. The second one, activity A. Activity A will start by the finish of the start, which is at time 0. So we'll use the 0 as the earliest start. The duration is 2. 0 plus 2, then the earliest finish is 2. And we are dealing with weeks here. The units are weeks, 2 weeks. For activity B, the earliest start of B is 0. It does not need A as a predecessor. It can start as soon as A starts, so it will start also at time 0. The duration for B is 3, so the earliest finish will be 3. For C, it needs only A to start. Since A finish at 2 weeks, then or at time 2, then we can start at time 2. The duration is 2 weeks. That means it will be done at 4. 2 plus 2 is 4. For activity D, we have 2 predecessors, A and B. D to start, for D to start, we need to finish both A and B. But A will be done in 2 weeks. But unfortunately, I will not be able to start D after 2 because I'm still waiting for results from B or output from B that I can use in activity D. So I have to wait for B to be done. That's why I will take the maximum of these 2 nodes to start. So the maximum of 2 and 3 is 3, and that will be the early start for activity D. The duration is 4, then it will end, the earliest finish is 7. 3 plus 4 is 7. And so on. We can go with all the nodes until we are done. If you go back to the table, and calculate these, 2 plus 3 is 5, 5 plus 2 is 7, 7 plus 4 is 11. 11 plus 4 is 15. 15 plus 3 is 18. 18 plus 5 is 23. 23 plus 2 is 25. So we are assuming that it will take 25 weeks to finish the project. While if you go to the diagram that we just finished, or the network diagram that we just built, you can see that it will end in 15 days. 15 days. So it's not by adding the weeks or the duration for each activity as is, it's by the sequence of activities and if some of them can be done on parallel or not. Now let's go with the backward pass. To go with the backward pass, we need to understand some of the rules. For the latest finish time rule, if an activity is an immediate predecessor for just a single activity, its latest finish equals the latest start of the activity. If an activity is an immediate predecessor to more than one activity, its latest finish is the minimum of all latest start values of all activities. Now we are going in reverse and we need to learn how we can calculate that. So the latest start time of an activity is the difference of its latest finish time and its activity time or duration. So let's start going back with the example of the Milwaukee paper. We finished at 15, so the latest finish is equal to the earliest finish. Latest finish is equal to the earliest finish. 15 minus 2, that means the latest start is 13. So the latest start will be 13. Now H is the successor for both F and G. So I will use the 13 for both of them. 13 and 13. Now for F, 13 minus 3, then the earliest or the latest start 10. The latest start at week 10. For G, 13 minus 5, the latest start will be 8. For E, I'll take the 8 and put it as a late finish. 8 minus 4, then the late start is 4. Now going back to C, we have two successors, F and E. The latest finish for F, or the latest start for F is 10, and the latest start for E is 4. We take the minimum of these two and we use it as a late finish for C. So the latest that C can finish is 4. 4 minus 2 is 2. And we continue with the rest of tasks until we have 0 or we go back to start. Look at the different tasks. What do you see? You can see in F, in D, and in B that you have a slack time. So actually you can finish either the 7th week or the 13th week or any time during that. The earliest finish is 7, the latest finish is 13, and that's a lag time. The same for D and the same for B. So to compute the slack time is equal to latest start minus earliest start, or latest finish minus earliest finish. This is the earliest start, this is the earliest finish, latest start and latest finish for each activity. We subtract and you can find that B has a slack of 1 week, D has a slack of 1 week, and F has a slack of 6 weeks. Slack means we can start right away, we have time to slack in this activity, so it's not important to start right away. Delay it a little bit, but not too much. The maximum delay that I can do for B is 1 week, for D is 1 week, and for F is 6 weeks, which is too much, but I can delay it up to 6 weeks. After that, I have to start and finish the project. Which means that these activities are not critical, So if any delay happens, that will not affect the schedule. While if A was delayed, it has 0 slack. So any delay will push the schedule to the front. So that's the problem. We don't need to push the schedule. Actually, always you would like to come within time. That's why we say these kind of activities that can push the schedule or delay the schedule is called critical activities. Since they are critical activities, they will form a path. That path is called the critical path for the project. Any activity on that path might delay the project. If something happened to these activities, it might delay the whole project. So I need to take care of these activities, make sure that they are finishing in time. Then the critical path for the Milwaukee paper is A, C, E, G, H, and that's the critical path. Those activities on this path are critical activities, doesn't have any slack, while the other 3 activities B, D, and F has slack time that will not affect the critical path or the project schedule. But again, we have limitation and we have to calculate the slack time for each of these activities and make sure that we are not exceeding the limit to affect the schedule. So we have a range or certain amount of time that I have a slack with or I can utilize, but not to exceed that limit. What if I need to crash a project to shorten it? Sometimes it's necessary when the customer requests that or the management requests that, and I need to work on just looking at the project network diagram to shorten or to compress the project to be done within a certain period. To do that, we need certain strategies. Now remember that I told you that we don't have any slack in the other activities. So if we don't have any slack, how can we crash the critical path or the project schedule? First of all, we need to examine the critical path to see if you can move some tasks of the critical path. If some of these tasks can be removed or moved to another place, then maybe we can start it on parallel, or we can handle it in a different way to crash the critical path or the project schedule. We also need to look for tasks which can be done simultaneously or in parallel instead of sequentially. We need to look for tasks which may begin when part of the previous task is done. So instead of waiting for task A to be done, I can start task C at the middle, because I'll need the output or the whole output or the whole outcome from A. I need just few outputs, and I can just start C. Look for tasks that can be assigned to more than one person. So I will have like partial time for each activity. Look for possible changes to task dependencies and beware of added risk when you do that. Some of the concerns when we do that is the increase in risk, and more communication and coordination is needed, whether with the customer or with the team or with the supplier. Those are examples of compressed schedules. For example, if you look at A and B, we started A as soon as we started A, so we had that ability instead of waiting for A to be done. The same for C and D here. So I did a compression for C and D, A and B, and now we have compressed schedule that can crash the total project execution and finish before the scheduled time. Some of the strategies that being used by some of the management is to add more time for the task. So instead of saying that the task can be done in 1 week, I will say it will be done in 1.5 weeks or 2 weeks, in case something like that happen, or in case the customer asks for a compressed schedule. So they will have a slack actually for every task, including the critical path, because they estimated an extra time, or they added an extra time during the estimation of task duration. The problem with that it will be maybe if you have a slack for a certain task, that you will not do it until that level or that when the task comes, but it will be good on the project level. And it's good for the project level because it accounts for risk. It has incentives for the management, and it has 5 to 10% better outcome for the schedule. Now the other way to do it, we did that you manually going through the nodes one by one. The other way to do it is to create network diagram in Microsoft Visio. And to do that, just open Microsoft Visio, then click on the network diagram and open a new Visio drawing. Then select schedule. Actually, it should be this one. Let me fix it. and it should be schedule, not network, it should be schedule. So open a new Visio and select the schedule, not network, schedule. The network here in this case refers to a computer network diagram, which is a bunch of computers like LAN, WANs, can be drawn in under this diagram, while we are looking for project network diagram, which is a schedule. So click on the schedule and you can create what's called a paired chart. Paired chart. Then you can start entering the tasks. Actually, you know what? Let me open Visio myself and I will show you how this can be done easily. How we can add the Milwaukee paper network diagram as an example. So let me end this show, then let's go to Visio. And we click on pair chart or schedule. So pair chart, and you will see these icons on the side. You just take the part 1, drag it and drop it on the screen. To play with the numbers, we can just click on this one and say 0. Duration is 0, early finish is 0, and you can go backward later on, but let's go forward, and you can say the task is start. Click on the arrow, the pointer again, and now you have the starting point. So you can click on this one and that will create another one for you. You can move it up and then another one which is down, and that will be A and B. So for A we have start at 0, duration 2, so we will have earliest finish at 2, and the task name will be A. And again we'll go to the pointer and go back to B. For B we have 0 and we have 3 duration, so the earliest finish is 3, and change the name to B. Then we can continue with the different tasks. Let me just go to the table so I can create the other tasks. For C, it doesn't need B to start, it needs only A, and the early start, actually I will use a pointer here, the early start is 2, duration is 2, then the early finish is 4, and the task name is C. Go back to pointer. Then for D we need both A and B, and I can just create a connection between A and D. So D needs A and B to start. Go back to pointer. The early start for D will be 3. Oops. This is D, and the early start will be D. The duration for D is 4. Then the early finish is 7. Then we have, after C, we have 2, we can move this one up, and this one here, and then connect these two. For the earliest start for F, it will be 4, duration is 3, earliest finish is 7, and the name for this one is F. For D, or for E, I'm sorry, for E, it's 4, duration is 4, earliest finish is 8, and then the name is E. Then we can actually connect D with G and A, E with G. So we have task G, and task G is starts at 8, duration is 5, and the early finish is 13. Task name is G. We can move this one and that will be task H. That will start at 13, the duration is 2, the finish is 15, and the task name is H, and you can go backward after that. And this is how it's done. in Visio. So going back to our presentation, you will see that this is the Milwaukee paper network diagram being done through Visio. Now, how to use Microsoft project to create network diagram. We can actually build the Gantt chart and the work breakdown structure, and from there we can create a network diagram. So let's start entering the tasks as given in slide 37 in the table that has the list of tasks. And for the ease of use, what I'm going to do, I'm going to open Microsoft project and then just copy paste, if I can, the description. I'll see if I can, because sometimes it doesn't work, but let's see the possibility of copying that. So let me again in the slide and open Microsoft project. And again, I will go to slide 37 to try and copy and paste the task and the duration from that one. See, it doesn't, it's not working. Let's see. Yep, it's not working. Anyway, let's do that. Build internal component. Actually, that will give you a training on how to create the Gantt chart or the work breakdown structure again through using a Microsoft project. Okay, let's modify roof and floor, and that's 3. Then construct collection stack, and that's 2. And then pouring concrete, and install the frame, and that will be 4 days. I'll make this bigger. Now remember, is to start C, I need A to start. I need in this case 1 to start pouring the concrete. I need 1 and 2, A and B, so 1, 2, and then we have to build high temperature burner, and the duration is 4. and it needs 3 to be done. Then we have to install pollution control system, and that will take 3 days. Predecessor is number 3, which is C. Install air. I would like to keep it consistent, so all the same. Air pollution device. And that will take 5 days. The predecessors are 4 and 5. Then inspect and test. That will take 2 days, and the predecessors for that is 6 and 7. So now I have the project. I can just move this here and show the Gantt chart diagram. So I have this one. Now that shows the work breakdown structure. Actually, we can go here and say insert column, or I will hide this column first, hide column, and then insert column. Let's do the work breakdown structure, WBS, okay, and it's organized as 1, 2, 3. I don't have any indented activities or tasks within the main tasks, so I have 8 major activities, and this is it. That's why I have 1 to 8. I have the predecessors here, and I have the Gantt charts. So this is the list of activities, the Gantt chart. Now, how can we develop a network diagram in Microsoft project? It's way easier than using Visio, than constructing Visio. All what we need to do is to go to View and select Network Diagram View, and I will get the view for the activities. This is the network diagram. This network diagram includes the task ID, start date, finish date, and duration. And I can add down here the resources that's assigned to each task. Now, the best about this network diagram, first of all, I didn't have to do it. It was done automatically by Microsoft Project once I entered the information for or the list of activities for the project. The second thing, can you see the red here in the graph or in the diagram? What does it represent? The red path is the critical path. So actually the highlighted tasks in red means they are critical tasks. So just by looking at this, the project manager can identify the critical tasks, can identify the critical path. Not only that, he can look at the duration and know that the project will be done in 15 days and it will finish. It will give him the date that that task will be done or that project will be done. So the project will be done or delivered in this date. That will be all for this session, which included building the network diagram. It included using Visio and included using Microsoft Project. If you have any questions, please email it to me and I will be more than glad to help. Thank you.